Hello! Have you ever wondered what gives AI its superpowers? What is the secret sauce behind the services like ChatGPT or Midjourney to let them create and learn? Or how does your phone instantly recognize your face, even in the dark? The answer, in large part, lies in a special kind of brain. Not a human brain, but a silicon one. We're talking about AI chips. In the next 10 minutes, I'm going to break down what these are, why we desperately need them, and how they're fundamentally different from the processor you heard of before. Stick around and you'll learn, and I hope you will enjoy. Okay, so to understand why we need a special chip, let's first talk about what we already have in almost every computer, is CPU. Central Processing Unit. Think of CPU as a master chef. Yeah, like the show that our moms are obsessively watching for some reason. It's incredibly versatile and super fast. Not the show, CPU. At handling a wide variety of complex sequential tasks. It can bake a cake, then go to grilling a steak, but it can only really focus on main dish, like a one dish at a time. Then we have the GPU, or Graphic Processing Unit. A GPU is like an army of kitchen assistants. It's a parallel processing beast. It can cook a complex 5-course meal, but it can perform the same simple task, like chopping onions across a huge amount of ingredients simultaneously. This is why GPUs were first adapted for AI. Deep learning involves tons of repetitive parallel math. But even GPUs have critical weaknesses when it comes to the massive scale of modern AI. And that weakness has a name. The von Neumann bottleneck, or the memory wall. I know I butchered it, but bear with me. Imagine our army of cooks in the kitchen, but the pantry where all the ingredients are stored is down the hall. For every single calculation, a cook has to run to the pantry, grow out one ingredient, run back, chop it, and then run back to the pantry to get the next one. The cooks are super fast, but they spend most of their time just running back and forth. This constant data movement between the processor and the memory is the bottleneck. It wastes a massive amount of time and energy. This is where AI chips come in. They aren't just a faster chef or a bigger army of cooks. They are a completely redesigned kitchen. AI chips are built to minimize that data movement. One of the key ideas behind many AI chips like Google's TPU is something called a systolic array. The name systolic comes from the heart's circulatory system, and it's a great analogy. Data flows through the chip like blood through a heartbeat. A piece of data enters a processor, gets multiplied or added, and the result is immediately passed to the next processor in line as a new piece of data enters the first one. The data is constantly moving and being processed at the same time. There's no running back and forth in the pantry. The ingredients flow right through the assembly line. This makes it instantly efficient for the core math of AI. Matrix multiplication. Imagine you and your 3 friends decide to open world's most efficient but slightly unhinged food truck. You specialize in one thing, the Insta-Taco. The whole process is on a fast-moving conveyor belt. Like, it's Insta-Taco, like instant. Get the idea, right? Yeah, I bet you did. Okay, your team is the processor, and each of you has only one job. Leo, the tortilla slapper. Cute names. Just warning, it'll be cringe, but cute names. At the start of the belt, his only job is to slap a warm tortilla down, like, if you ever did a taco. I did once, and in America, out of really curiosity, but it's like It's kind of like tantuni in a lavash. It's just taco, yeah. And they stole the Greek yogurt. Like, I'm pretty sure we came up with yogurt, not Greeks. And, oh my god, I gotta tell you that. They think dolma, sarma is from Greeks. They think so. Oh god, it made me so mad. I like went and told customers and employees just, it's from us, it's not Greek. Don't steal us things. Don't steal from us, okay? But moving on. Enough yapping. So yeah, Leo is a tortilla slapper. And there's Chloe. As a tortilla passes, she has exactly 0.8 seconds to plop the perfect scoop of spicy chicken into it. She treats her scoop like a surgical instrument. And us, we are third. We have a glorious triple nozzle dispenser that shoots out lettuce, chicken, and sour cream all at once. Your timing has to be perfect. And there is Ben, whose only purpose in life is to fold the taco into its final perfect form. Now, an AI chip is like the system on a perfect day. The conveyor belt, the data flow, moves at a super fast but perfectly calculated speed. The systolic era in action, Leo slaps the tortilla, then it zips to Chloe, who scoops the meat, then it flies to you, you blast it with toppings, and Ben folds it into a masterpiece. It's beautiful, high-speed ballet of taco perfection. Data flows in one end and a perfectly processed result comes out in the other. No one has to run around, no one has to wait, it's just pure rhythmic efficiency. But here's the funny part. What happens when the timing is off? Imagine the conveyor belt suddenly doubles its speed without any warning, for some reason. We don't know, and we thank Beyonce for that. Anyways, what happens? Leo, in a panic, misses the belt and starts slapping tortillas onto the walls and everywhere. And Chloe, trying to keep up, ends up launching scoops of kitchen into the air like a catapult. You're trying to time your topping, blast, completely miss a taco, and pressure wash Ben directly in the face with a stream of cheese and sour cream. And Ben, and now blinded by the dairy, is just frantically trying to fold anything he can get his hands into. A napkin, his own hat, a passing seagull, anything. It's complete chaos. That chaos, that's what AI chips are designed to prevent. They are perfect, hyper-fast taco assembly line where the conveyor belt speed is always perfect. The data flow through flawlessly and nobody gets blasted in the face with cheese. It's all about synchronized, non-stop forward flow. Another clever trick is using reduced precision. For most AI tasks, you don't need extreme precision. You don't need to know if a pixel is like 0.543 something shades of red. Just knowing it's about half red is usually enough. By using less precise numbers, say 8-bit integers instead of 30-bit floating numbers, the calculation becomes simpler, faster, and requires less energy. It's like using smaller, simpler measuring cups. You can fit more of them on your assembly line. So this isn't just a theory. These chips are everywhere. Two big acronyms you'll hear are TPUs and NPUs. TPUs, or Tensor Processing Units, are Google's custom-built AI chips. Tensors are just a fancy name for the multi-dimensional array of data that AI models use. These are heavy lifters in the Google's data centers that train massive models and power services like Google Search and Google Translate, which I used to understand how to say circulatory. Then you have NPUs, or Neural Processing Units. This is a more general term for an AI chip designed to go into your personal devices. These are the tiny AI brains in your smartphone, your smart camera, or even in your car. But we don't have that, because we are broke. They enable Edge AI, performing AI tasks directly on the device. When your phone's camera creates the beautiful portrait effect, it's the NPUs that doing that. It's identifying the person, blurring the background instantly without having to send your photo to the cloud first. That's faster, more efficient, and much better for your privacy. That's why this video is sponsored by NordVPN. The development of AI chips is not just an incremental improvement, it's a game changer for two main reasons. First, they make large-scale AI possible. Training models like GPT-4 on traditional hardware would be astronomically very expensive and could take years. We don't want that because we use ChatGPT for everything, even for this. AI chips make it feasible to train these gigantic models, pushing the boundaries of what AI can do. Second, they bring AI to the edge by putting powerful, efficient NPUs in our everyday life. We get intelligent features that are instantaneous and private. Imagine a pair of glasses that can translate a foreign menu for you in real time, right before your eyes. That's the future that on-device AI chips are building. I wish we had that, but we probably couldn't afford it. But if we did, when we went to America, that would be very helpful because English is fine, we can understand and we can talk, it's okay. But Chinese? We went to the Chinatown and they didn't bother to translate the menus and we were just staring at the menu and the menu was staring at us basically. And we just looked at the waiter and the menu and the waiter got the point, like, yeah, I gotta come. And he came and we were like, what is something? Racist, I swear, it was something like that. I swear the guy's not like tin ton ton tin song, okay. I swear it was like that. And he was like, it's just steak with some onions in it. And we were like, cool, we get that second one because we didn't like the idea, but we couldn't ask what the second one was because he was looking at us like we were just stupid people. Yeah, that would be great. So let's recap. Traditional processors like CPUs are master chefs, but they struggle with the massive parallel workloads of AI because they spend too much running to the memory pantry. AI chips are a new kind of architecture, like a super efficient assembly line that brings the processing and memory closer together. They use clever designs like systolic arrays and reduced precision to achieve incredible speed and efficiency. From the giant TPUs in the cloud to the tiny NPUs in our devices, these specialized brains are the unsung heroes of AI revolution. They are a perfect example of how the needs of software are driving a radical evolution in computer architecture. The next time your phone does something feels like magic, you'll know the secret. It's not just the code, it's AI chips. And all of these chefs and kitchen enology made me kinda hungry, so I'm gonna go eat. Bye bye! The name systolic comes from the heart circulatory system. Circulatory. Circulatory.